This is section 5.7. We're going to talk about using congruent triangles. So we have something called CPCTC, and that stands for corresponding parts. So the matching parts of congruent triangles. So if we know triangles are congruent, we can match up their parts, are congruent. So we can now say the parts that went together are in fact the same. So we're going to use CPCTC when asked to prove that segments or angles are congruent. But first we must prove that the triangles are congruent. So we know our methods for showing triangles congruent are things like SSS or side, side, side. So if I can prove two triangles are congruent using only their sides, I can now say their angles are also congruent to each other. So for example 1, we're going to explain how to prove the statement is true. So what I can do here is after the reflexive, I can prove the triangles are congruent by SSS. And then I can say that these angles are congruent by CPCTC. Corresponding parts of congruent triangles are congruent. For B, I can show, I highlight one of my triangles. I had an angle here, I had a dash here, I had an angle here. So this looks like two A's and an S. The S is outside of them. So my triangles are congruent by AAS. And now I can say that my sides are congruent by CPCTC. So here's one for you to try. Pause right now if you'd like. Answers are posted on Google Classroom. So here we have a proof, and we notice our proof statement is no longer triangles are congruent. Step 5 is where we have triangles are congruent. So we're going to prove something after the triangles are congruent. All right, but I know I can fill that in. I know PS is parallel to QR is given, and step 3 is also given, so that's angle P is congruent to angle R. So those are all the things I can fill in right away. So here we have alternate interior angle theorem. If you recall, when we're tracing the parallel, oh, let me try that again because that was an awful tracing. When we trace the parallel lines and connect them, we make a Z-looking shape, and the corners, the points where the lines meet, are where my alternate interior angles will be. So that's this corner and this one. So that's angle PSQ and angle RQS. We have to use 3 letters because there's more than one angle at Q and more than one angle at S. So here we have angle P and angle R were congruent. That was given. That was not marked for us. I'm going to get rid of this so we're not too overwhelmed with all the markings. I'm going to put those angles back that I added. We have our other given angles. Now in step 4 it says segment SQ is congruent to segment QS. Those are the same letters, and they're talking about this segment here in the middle. Congruent to itself, so that is reflexive. Now we have the triangles are congruent. So they said triangle QPS. So in this triangle here, Q was unmarked, P I had marked with 2, S with 1. So unmarked 2, 1 would be SRQ. And my method is 2 A's and an S, and when I connect the A's together, it did not go through the S, so that would be AAS. And immediately following triangles being congruent by either SSS, SAS, ASA, AAS, or HL, we can now use CPCTC to say parts of them were congruent, right? The P and the Q matched up with the R and the S in our congruent statements. So that is CPCTC. All right, another example together. So this one mentions angle W congruent to angle Y is the last thing we're going to say. And you notice above it, we said that two triangles are congruent. I can immediately right now put CPCTC here. I know after triangles are congruent, those things will be congruent by corresponding parts of congruent triangles are congruent. All right, we know step 1 is also given. And step 3 says given as well. So my given said x is the midpoint of wy and zv. We've only mentioned wy in step 1, so I'm going to take this same sentence and write x is the midpoint of the other one that we haven't mentioned, zv. Okay, so now definition of midpoint. If I said that wy got cut in half, then the two pieces of wy should be the same by the definition of midpoint. So that's wx and yx. Then I said that zv got cut in half. So this line now got split in half. So that's going to be vx and zx. Here we have angle wxv, which is right here, and angle yxz, which is right here. So if I mark them in the picture, it's easier to see that these are vertical angles. So we're going to use the vertical angle theorem. Now we have our triangles are congruent. So wxv, so the farthest middle v will be yxz. And this, I have two s's and an a, and when I connect the two s's, it points to the a, so that is SAS. Right? And now the w and the y match up, so they are corresponding parts that are congruent because the triangles are congruent. So here's one for you to try. Pause now if you'd like. The answer is posted on Classroom. All right, these are just more practice. It's nothing different. So here, segment JK is going to be congruent to segment JL. It's immediately following triangles are congruent, so I can fill in my reason is CPCTC. I also have JM bisects angle KJL was given. And step 3 was given as well, so that was angle JMK congruent to angle JML. So JM bisects angle KJL. I'm cutting angle KJL in half. Angle KJL was this big angle here. If I cut that angle in half, the two pieces of it will be the same. So the definition of bisector is going to be for angle KJM, and angle LJM. All right, let's get rid of all this mess first. Put those marks back in. We see in step 3 the given is angle JMK, so this angle here is congruent to angle JML, this angle here. Step 4 says the reflexive property. So JM is a segment that's in both pictures, so we can say that JM is congruent to JM. And now I'm ready for my triangles to be congruent. So I have an A here, an A here, and an S in between them. So when I connect the two A's, it passed through the S. So my method would be ASA. And we have triangle JMK, so that should match with JML. There's one final proof for you to try. You could do that now, but this is also the end of the lesson. So this was section 5.7, using congruent triangles.